Alright, good afternoon. My name is Kevin Espinoza, and today I'm going to be presenting my solar system project. Alright, so we're first going to start off with terrestrial planets, and basically these are pretty much rocky, high density. Oh, these planets are tend to be more rockier compared to Jovian planets, because Jovian planets are just pretty much gas and ice, and these are rockier and they have higher density, and these are actually closer to the sun in our solar system. And they have a few oh my bad. They have a few moons, but they don't have any rings like the Jovian planets do. And where one of the major differences is that it comes to size. Terrestrial planets are way smaller than Jovian planets. Like the size comparison, like yeah, it's pretty big. And and the four planets is just Mercury, Venus, Earth, and Mars, as you can see right here. And and actually, uh, two of the most famous planets from terrestrials that are mainly mentioned the most is Earth and Mars. What are Jovian planets? Basically they rotate on, the axis quickly and around the sun. And the thing about Jovian planets is that they have low density and they're pretty much huge gas giants. They have thick gaseous atmospheres, cold. They're really cold because it tends to be farthest from the sun. Most of them, yeah, they all have rings and they all have many moons. Like comparing to like planet Earth, when you have one moon, they have like a lot. And what are the differences between Jovian and terrestrial planets is that Jovians are contain large amounts of gases and ice. And also the differences within density and like also the chemical makeup and at the rate of rotation are other ways in which two groups or planets differ. Because the thing about, we have 8 planets, the terrestrial planets are closer to the sun and Jovian planets are farther. All right. How was the solar system formed? Oh, pretty much a cloud fell perhaps due to a shockwave close by a detonating star. And this is called a supernova. It's a pretty cool name. And at the point of the residue, the cloud there's like this residue when the supernova exploded, a like cloud fell down and ended up creating like kind of like a whirl, like a little tornado, I guess you can say, sort of. And pretty much it ended up creating material. And pretty much. And it's kind of like a mystery because we exactly don't really know, but we're just kind of like a theory. But according to the nebular theory, the sun and the planets were formed from a rotating disk of dust and gases. Yeah, but it's pretty cool. And the structure of the sun. The sun is the star in which the planets orbit all around. The sun's in the middle and all the planets orbit around it. And we could pretty much divide the sun into 4 parts. It has the solar interior, the visible surface, and the photosphere, and 2 atmospheric layers, the chromosphere and the corona. And its gravity actually, that's what causes all the planets to rotate around the sun. And and pretty much these are the levels. We have the photosphere, which is the first, as I'm gonna start from the core. Core is like the middle. That's where all the energy comes from. And then you have the radiative zone, and you have the convective zone and the corona. And right here, as you can see, solar prominence and solar flare. These are pretty much like little things that happen within the surface of the sun. And the sun actually generates a lot of energy. Um, for example, like in Mayan culture back then, like the indigenous, like they worship the sun because the sun would provide. And actually, the sun's very important to back then because they would view the sun as a god. It was pretty cool. But when I went to Osal, they're like telling me about like how the sun's like is worship because how much it provides crops and all that. And you have pretty much all these spheres, and yeah, they're pretty cool.